So today we are going to solve this lead code problem number 53, maximum server array. I think this is the one of the most common question in interviews. And in order to solve this problem, we'll also explore the Kadane's algorithm, which is also a very popular algorithm. Okay, so if you read about this problem statement, it's saying that there is an array is given. Okay, so what we have to do, we have to return a largest sum from its subarray. Uh, Remember that this saying that we have to return a largest sum from the subarray. What is a subarray? A subarray can also be a array of this full length is also a subarray of this array, or any array or any elements from this array, a contiguous element is belong to the this subarray. Okay, so if I say my arrays is minus 2 comma 1 comma minus 3, this is also my subarray. If I say 4 comma minus 1 comma 2, this is also my subarray. So it's saying that we have to return a larger sum from all of these possible subarrays. Okay, and here is a constraint. If you see the constraint, there's a number of lengths should not greater than 10 to the power 5, and each elements can also negative and positive both. Okay, so how we'll solve this problem? So our initial brute force approach is simple, right? Where either we'll all generate all of the sub array, and okay, there's a sub array. Let's say I'll generate all of the possible sub array, and I'll sum up all this sub array. Okay, and whatever is max of this sum, I'll return that. Okay, so this is the brute force approach. And other approach, what we can follow, uh, that is what we'll do. Suppose this is the array 1 comma 2 comma 3. What we'll do, we will first pick this element and we will iterate on all of the elements. Okay, starting from here. So what we'll do, we'll see that this will count the sum of this array one by one. So suppose if I'm denoting this uh, index I, then I'll do, I'll take a constant variable, let's say count equal to 0. I'll iterate the range from I comma, let's say length of this array. Okay, I'll iterate that. And what I'll do, I'll before this there is another, okay, this is the second for loop. So what I'll do, I'll just see that I'll just add all of the values in my counts. Okay, nums of our, we can say array of j. Okay, and there is another variable. This variable will basically track of the max value. So let's say there is a variable max underscore sum. Initially we can pick 0, or most of the people using the first element of the array. Okay, so in our case it will be the 0 or array of first element. So we'll check that if our count is max, so max sum on each iteration, we'll check this max count comma max sum. Okay, if this is the case, then we'll simply return max underscore sum. But this there is another for loop, like this is I, and when your I will move on the second element, the a whole this for loop will execute again. So the total complexity for this problem will going to be increased to big of n square. Okay, and for this for loop, and for this I that we are iterating on top of this. So this is the basically and space complexity. This is your time complexity. Space, we are not using anything here, so space will be constant. Okay, so there is a this is the big of n square complexity. There's another approach like that we discussed earlier. This is called divide and conquer. Okay, if we follow this approach, basically we will divide one by one, and the second step will basically sum of this array, and we will return the sum of this array. So if usually divide and conquer takes n log n complexity, so this is also not optimal solution for this problem. So if we see that optimal solution, if we can further, we can try to optimize this log n. So what we can do, there's a scientist whose name is Kadane. He proposed a solution. Okay. So what he's saying, like suppose we have a array 1, comma 2, comma 3. He's saying that let's pick a two variable. Okay. Let's pick a two variable like above. This is sum. Let's say I'm assigning this to array of 0. Okay. This is the first variable. This is the second variable. Initially, second variable also nums is array of 0. Okay. What he's saying, just iterate on this loop, on this array. Okay. 1 comma length of array. And he's saying, whenever you're iterating, you have a count here. Okay. See if your count, what if whatever is max, is your max is this array of I, count plus array of I. Okay. So he's saying that see that whatever is maximum, just assign that value into the count. And second step is, if you found that in each steps we will repeat the same thing whatever we are doing here earlier, we'll do the same thing for the max sum. Okay, our max sum will be as it is, max sum equal to the max of max sum comma count, and at the end we can return simply max sum. Here you can see we are using only one for loop, which is big of n, and there is no space, so this is the time actually, and there is no space, so this is going to be big of only constant. Okay, so we can move on the lead code. I have already written this problem, so cool. So here is the problem that the first approach that we discussed. Sorry. So yeah, so we are assigned the max sum value here, and we are iterating first on nums. Okay, I comma v. Yeah, there's no need of v, so we can simply iterate. We can use the range here, and what we are doing, we are taking another variable which is count equal to 0, and we are running another loop. Okay. Uh, yes, and after that we are just summing that, adding each value in the count, and we are saying in each steps we are saying that if our count is greater than max, then we are replacing max with our count. Okay. If I'll run this, this is a small input, so this will run successfully. But if I'm going to submit this, this will tell me that the time exceeded. Yeah. Let's move to this cadence algorithm. This is this approach number 2. So what we are doing here maxim pick a variable just assigned to first element of this array, and there's another variable which is count equal to assigned to the first element of the array, and we are iterating over the numbers. Okay, we are iterating since we are already counted here, so we are iterating on second element from second element. And what we are doing, we are just adding to count num of I, and here we are adding to count, and we are checking that whatever the maximum, either individual number is the element is the maximum, or the this element uh, with the count is maximum. So we are picking the count, and each iteration we are checking if our count is the greater than this variable maximum, then we are just assigning that count, and we are returning that. So if I run this, this will execute quickly, and if I submit this, this will be accepted. Cool. Thanks all. Thanks.